Okay, so you did prisms last class. That was our last video, and that was two parallel bases with lateral sides, lateral area around the edges. And now we're doing pyramids, which is just one singular base, and then all those lateral edges, come up and they come to a pointy edge, right? So now we will see that here. So maybe a better definition, we can read this. A pyramid is another special type of polyhedron with only one base. The pyramids we will study will be regular pyramids. So that means the base will be regular. So it'll be a regular triangle, a regular hexagon, a regular square, or quadrilateral, which would be square. So the base is a regular polygon. All lateral edges are congruent. So your lateral edges here would be congruent. All lateral faces are congruent, so all these triangles would be congruent to each other. All lateral faces are congruent isosceles triangles, right? So they're congruent isosceles triangles. The height of a lateral face is called the slant height of L, or sorry, we call that L. It's not like that. So you go from the top down, we cut this triangle into two congruent parts, right? But this right here is the altitude of the triangle. But this altitude of the triangle is also known as the slant height. Okay, now that's different than the actual altitude of the triangle. We'll talk about that in a minute. Well, I guess we'll just talk about that now. It says the altitude of the triangle meets the base at its center. So the altitude goes from this tip all the way down to the center. So notice this is the center, so that means that all these pieces right here are equally distant. Right, so equally distant there. So this is 90 degrees. So this blue line is the altitude of the actual pyramid. So this is the pyramid's altitude. This is a slant height, which is the altitude of a lateral edge, a lateral face, sorry, a lateral face. These are lateral edges. So then it says here, let's name the base. So the base is down here, right? This is a square, that's my base. I don't know if you can see that very well. Then we have a lateral face. A lateral face is going to be one of these triangles. So if I did this would be a lateral face right here, this triangle. Lateral face. And then we have our lateral edge. So lateral edge, blue and purple, any of these right here would be a lateral edge, right? Remember, the base edges are the ones that go around here. So these are the base edges. This would be a lateral edge. And then, of course, we have the vertex. So this right here would be the vertex. Of course, we have lots of vertex points where these two segments intersect, but this is the ultimate vertex of a pyramid, the top where everything comes together. Pyramids are classified by their bases. So the pyramid shown here is what? Is a what pyramid? You could say a rectangular pyramid, a square pyramid, right? So a square pyramid. The base is a square. Remember, the base needs to be regular, so that's going to be a square. If the square pyramid has base edges 10 and lateral edges 13, find its slant height. So it has a base edge, which is right here, of 10, and a lateral edge. So this is a lateral edge, we'll call this. So that's 13. Then we need to find this slant height right here. Okay, well that's good. This 10, we know this altitude or the slant height splits this base into two congruent parts. So this is 5 and this is 5. So now we're going to use Pythagorean theorem to do 5 squared plus the slant height squared, which is always usually indicated as the letter L, equals, the lateral edge squared, right? So here's my right triangle, so those pieces. So now I'm going to use Pythagorean theorem, and you will see that the lateral edge is 12. So 169 minus 25 gives you 144. Square root of 144 is 12, and there you have it. Now what is the lateral area? So that just means the area of one of those triangles. So remember that's base times height divided by 2. Well, the base we can see is 10. The height we just said is 12. Oops. And we're dividing that by 2. So it's 120 divided by 2, which is just 60 units squared. So that's the area of one lateral edge. Or sorry, that's the area of one triangle, but we want to find all of the lateral area. So how many triangles go around this? Well, if there's 4 base edges, that means we have 4 triangles. So we're going to multiply that by 4. So, excuse me, but the total lateral area is 240. Sorry about that, I stopped too soon. So the total lateral area is 240 units squared. And then finally, what's the total surface area? Well, the total surface area is adding that lateral area plus the base area, right? So the lateral area we said is 240, and then the base area, well, this is a square, so it's just 10 times 10, right, or 10 squared, that's 100, and 100 plus 240 is 340. So I get that the total base, or total surface area, excuse me, is 340 units squared. Okay, the lateral area can be found using the formula 1/2 PL. Okay, let's see if that's true. 1/2 PL, where P is the perimeter of the base. Okay, so the perimeter of this base times L, the slant height. You would take 1/2 the perimeter of the base and then multiply it by the slant height. Well, let's see if that works. So the perimeter of that square, it was 10 times 4 different sides, right? So here we have it up here. So that's a perimeter of 40. Okay, then we're going to multiply that by the slant height. Okay, 40 times the slant height we said was 12. That's 480. But then it says we're going to divide it by 2. So we're going to divide that by 2. We get 240. So yeah, that worked. Okay, that was the same. So the question is, why did that work? Can you explain why that works? Well, to get the area of your triangle, you have to take the base times the height, right? So the base, 10 times the height, which is 12, but there's 4 of them. But remember, in order to get the area of a triangle, you have to divide by 2, so we divide by 2. So one base times the height, right? 10 times 12 would be 120, but there's 4 triangles, so that's 480. But then each triangle is divided in half to get the total area, so it's 240. So you could also use this formula if you wanted to. Okay, the volume of a pyramid equals 1/3 the area of the base times the height of a pyramid. So the volume. So volume, remember, is 3-dimensional. If we filled up this pyramid, it would be all the space inside the pyramid. The area, the surface area is if you painted it or you covered it in wallpaper or paper, that would be the outside area. Nothing inside. Volume is everything inside. So how do you find the volume? Well, before in a prism, we did base times height. But now we're going to take base times height and divide it by 3, or in other words, 1/3 base times height. So now you have to memorize that as well. Okay, moving on. Leave all answers in radical form when possible. So now you're just going to practice. I would go ahead and push pause now and then see how you do, and you can check your answers with me momentarily. Good luck. Okay, let's see how you did. The length of the slant height, you should have gotten 4 centimeters. So slant height, that's this one, purple one right here, right? And if we know that the regular square pyramid has a base edge of 6, then we know this is split into 3 into 3. And then we know that the lateral edge is 5 centimeters, so we're making this right triangle right here. The purple, here I'll go over that again. Purple and across and up, that's a 3, 4, 5 triangle, right? This is 3, this is 4, this is 5, so that's 4 centimeters. Lateral area, so that's the total area. So I took the area of one triangle and multiplied it by 4 because there's 4 triangles, and I get 48 centimeters squared. So base times height divided by 2. Then there's 4 of them. The base area, well, it's just 6 by 6. It's a square, so it's 36. So the total area is 48 centimeters squared plus 36 centimeters squared, which is 84 centimeters squared. Now what's the volume? Well, you can't get the volume until you get this altitude. So first you need the altitude. So the length of the altitude looked a little complicated. So it goes from the center to the center of the square. So I drew that here. Right, we're trying to find the altitude, so I put a little a. And we have to find the diagonal of the square first. Well, if this is a square and each side is 6, then the diagonal is 6 root 2. So then this portion right here is half of that, which is 3 root 2. So if I square 3 root 2 and then add it to a squared, a equals 5 squared. Well, 3 squared is 9, 9 times 2 is 18. So 18 plus a squared equals 25. Subtract 18 from 25, I get 7. So the altitude is the square root of 7. Okay, that's just the altitude. So to find the volume, we do the area of the base times the altitude times the height divided by 3. So 3 goes into 36 12 times. So this is my final answer. You don't need to do anything with it, just leave it in radical form. Okay, a regular triangle pyramid. You should have gotten 54 centimeters squared for its altitude, or sorry, its lateral area. The base area was 4 root 3 centimeters squared, and then the total area, we just add those together, 54 plus 4 root 3 centimeters squared. So how do we get the lateral area? Well, they told us the slant height, which is 9. They told us the base, so base times height divided by 2, but then there's 3 of them, right? So base times height divided by 2, but there's 3 of them. And then the base area, well, that was a little more complicated, but remember it's an equilateral triangle with each side length equaling 4. So you take that altitude, this is a 30-degree angle, or sorry, a 60-degree angle, excuse me. So opposite 60 degrees is 2 root 3, this is 4. So base times height divided by 2, that's the base area. So we just add those up. And there you have it. And finally, number 3. The height of a regular triangular pyramid is 6 centimeters, so this is my height. Remember, the height goes from the tip of the pyramid down to the center of the base. That's 6. The radius to the base, so from here it goes out, and that's 8 centimeters. It's a little complicated, right? It goes out from the center to 8 centimeters. We did that in the last chapter, though. And now we have this blue right triangle with a slant edge, the altitude, and then here from the center of that triangle out to the vertex, because that's the radius. And if this is 8 and this is 6, that's a 3, 4, 5 triangle multiplied by 2, so that we know the slant height is 10. Now, did we even need to know that? I don't think we did. Anyway, area of the base. Well, how do you get the area of the base? You need to take this little triangle right here, and you have the radius, which is 8, so it split that 60-degree angle in half. So this is now 30 degrees, which means this is 60 degrees here. And if this is 8, this must be 4 root 3 because this is 4. Which means my outside base edge is 8 root 3 because there's 2 parts to it. So my base edge is 8 root 3. I multiply it by my height divided by 2. Wait, I'm looking. Yeah, sorry, because I'm just doing my base. My base edge is 8 root 3. I multiply it by my height here, which is going to be 12. By the time you do the 8 here and the 4 here, that's 12. Divided by 2, so it's 48 root 3 centimeters squared. But then my volume is taking the area of the base, multiplying it by the height, which is 6, the height of the pyramid. I was having a little blank out here when I was explaining before. And then we divide it by 3 because it's 1/3 because it's a pyramid, 1/3 that total volume. And you should get 96 root 3 centimeters cubed. So this is the base area, volume, and there you go. So that's pyramids. Just like a prism, except you divide the volume by 3, and then of course the lateral faces are different, so your surface area is going to be slightly different. And there's only one base, not 2, so that does change. Next, we're going to move into cylinders and circles, or cylinders and cones. Same thing, except our bases are circles. So watch that video next. Bye.